Getting a little out of hand there. Well, it definitely, it lights on fire, people. All right, guys, today we're talking about a new carbon fiber, CarbonX CF PA12 from 3DXTech. Now, this is a PA12 made using a high-modulus carbon fiber reinforcement and a specialty nylon 12 that 3DXTech chose for its printability, thermal properties, and chemical resistance. Now, PA12, or polyamide 12, which is nylon 12, is widely used in a variety of industries due to its excellent chemical resistance, low moisture absorption, and wide processing window, or the temperature range at which you can melt it. This particular formulation ensures very low shrinkage in the printed part, resulting in excellent dimensional stability with the carbon fiber, of course. This makes CFPA12 an excellent choice for tools, fixtures, and jigs. So here's the box and the spool inside that you'll get when you order off our online store, visionminer.com/materials. Comes in this nice thick plastic sealed bag. Now sometimes you might get it and it might not be vacuum sealed, but that's okay because you're still gonna have to dry it no matter what the first time it's out of the bag. Very, very important with all types of nylon. This one a little bit less so, but still really, really important. By the way, why do you want to buy from us? Simple. You get 3% back on every dollar you spend. That can be used towards nozzles, spools, glue, machines, accessories, more filament, anything you want. Plus, we're always on the phone to help you when you need it when you bought it from our store. So definitely check that out. We've got everything from machines to nozzles to filament and everything you need for high temp 3D printing. By the way, we're doing a comparison video of all the different nylons and carbon fiber filaments we got. So make sure you're subscribed for when that comes out. Okay, so now let's talk about where you're going to see this material in the actual real world. Common applications include everything from motor parts to fuel line connectors, coolant pumps, bushings, bearing pads in aircraft engines, charged air coolers, resonators, engine cover components, even heat shields sometimes, fuel cutoff and water heater manifold valves, connectors, high voltage bushings, motor housings, and even headlight components. It's also often used for prototypes of car parts, drones, and high durability mechanical components. Now, what kind of machine do you need to print this filament? First off, your nozzle temperature needs to go to at least 265 C up to 285, but in our experience up to 310 or 315 can be done depending how fast you're going. For the bed temperature, 90 to 100 Celsius is going to keep you good, and as far as adhesive goes, our nanopolymer adhesive actually works great, sticks it down to the bed very, very well, and from what we've heard from our customers and other vendors, it's one of the only things that actually works for the nylon 12 blends. As far as chamber temperature goes, it's recommended, but it's not required. It's definitely going to help on larger, thicker parts to keep that warping and curling down, but you don't need a heated chamber to print it. So your Ender 3, yes, you can print this stuff. As far as drying goes, you absolutely must dry this filament. Like almost every other thermoplastic, it needs to be dried before you melt it, otherwise you get little steam bubbles. Now PA12 absorbs much less moisture than the standard PA6 base materials, but it still absorbs a lot of moisture and must be dried before printing. You definitely want to keep this thing in a sealed container between uses, like one of our vacuum chambers, and you dry it around 90 Celsius for 4 to 6 hours if it's been exposed to too much moisture and becomes too wet to print, which you'll know from the surface finish. We do offer a full drying kit, including the vacuum chamber and some ovens, and it's the best way we've found to get all the moisture out so that your prints won't get ugly and weak. We're here to make it easy, and that's why we also made metal spools right here, which allows you to dry it at higher temperatures a little bit faster without melting the spool that it comes on. With nylon, a vacuum chamber is seriously important. It helps out a ton. Definitely check those out. And with the carbon fiber, our spools make it a lot easier to keep them spooled, especially near the end of the spool when the filament becomes a lot more brittle thanks to the carbon fiber. Now, let's talk a little bit about the material specifications. It's got a glass transition point around 165 C, while its heat deflection temperature is about 150 C, which means it's excellent in strength and stiffness over a wide temperature range, all the way up to 150 Celsius. Now for continuous use, like 10,000 hours or more, we're looking at around 120 Celsius. Now, thanks to the fact that it has very low moisture absorption, it's got improved retention of mechanical properties after exposure to humidity, especially over nylon 6, and it's got a lot better chemical resistance as well. It's also less dense than the companions at 1.16 grams per cubic centimeter. So so it's a lot lighter by volume. If I compared this to the other nylons, personally, I've noticed that PA12 is a little bit more brittle than PA6. It's definitely more beautiful in the surface finish, but PA6 is a bit tougher in general, at least the 3DXTech CFPA12. By the way, if this information is helpful to you, please hit that like button. It lets the algorithm know that our content is valuable and that you want more of it. And you might as well subscribe while you're down there. We've got a lot more of these videos on the way. Okay, so now let's check out some example parts. I'm going to start over here with these vases, right? We just, show you the surface finish and sort of what it comes out looking like. We've got a few vases that we printed here. And this material really comes out smooth and very, very nice. It does have that carbon fiber texture that comes in all carbon fiber filaments, so it's a little bit like very, very, very fine sandpaper on the outside, but overall it's very, very good looking. And it hides the layer lines a lot thanks to the carbon fiber, so these are actually printed at 0.2 millimeter layer height with a 0.4 nozzle at 0.6 extrusion width. So just an example of what you can get, and it's very ductile. I'm going to smash this here in a minute and then light it on fire, so don't go anywhere. Next, we've got this little part that we printed in all the different materials, and it's a electronics enclosure, and you can just really see how beautiful this material comes out. It's a very, very nice surface finish. It looks clean. The layer lines are hidden, once again, at 0.2 millimeter layer height on these. And as you can see, there was a bunch of support used here, and we just used the same material as support. We didn't do dual extrusion for this, just nylon as support with one separation layer, and the overhangs did really, really well. You almost can't even tell that there was any support there. So good bridging performance, definitely. Very, very nice. Over here we've got some jigs that we've done, and you can tell this one right here was a little bit too hot once we got up at the top. So one technique we do in the shop all the time is we'll just, like on this particular part, we'll drop it below the build plate and only print this top area until we get it right. Or we'll even go into a CAD program and cut this part out and then just print that until we've got it tuned, even while the rest of the part is really easy. And then once we've got that dialed in, we'll print the final part, which looks like this. As you can see, it came out fantastic. That little rim over there, there was a tiny bit of support right here. Came off super easy and clean, a little more support down there. Really, really, really high quality. This part is amazing. I've got some failed prints to show you here in a second too, but if you're curious and you need to test this material in your acid or your chemical environment or your high temp environment, or you just want to see how it is compared to the other nylons, we've got these little sample bars that we printed in every material. So if you give us a call, talk to us about your application, and we'll send you a couple of these so you can actually feel what the material's like and compare it to the other materials. We've got like 5 or 6 or 7 different nylons and carbon fibers and glass fibers now. So you can find all those at visionminer.com/materials. But these bars help you get an actual feel for it. Now, before I go and break some of these parts, I'm going to show you some of the failures that we had previously. Now this first vase, in comparison to the other one, you'll notice that up here, it started drooping and it looks like it just melted all over the place. And so that was basically it getting a little bit too hot up near the top, and it just didn't, the angle was a little too much, it just came out funky. So a lot of the times what we do is we'll actually split the process in Simplify 3D, and we can add some cooling fan up here, or we can make it go faster, or we can change the temperature for the different areas where there is trouble. Now, moving along to the next fail, it wasn't really a fail, it actually printed out very well. Nope, we got the same one there. It actually printed out very well, but I like to break things before we do it on camera. So, as you can tell here, the surface, or the layer adhesion, wasn't quite as good as we expected. The other nylons, you can crush it and you can put it right back to where it was, no layer adhesion issues whatsoever. But this filament ended up being a little bit more brittle. So as you can see there, it broke up and down the layers, but it also did have some layer adhesion. So we changed the temperatures, printed it again. So now that I've been talking about all this breaking of parts, let's do it right here, right now. And safety first, so get some safety goggles. I'm also gonna break these bars here, so I'm just gonna get my handy dandy Babco vise ready. And let's do the first test, which is taking the vase and I'm just gonna shove my thumbs through it. So we're gonna see how much it deflects, if it pops back out, where it breaks, how it breaks, isotropic, non-isotropic, how this material really reacts. We've done this with all the other materials, so if you're not already subscribed, if you haven't seen those other videos and you're curious, we've done the same test in almost everything. So let's do it. Just gonna stick the thumbs in, so we definitely have some bounce back there. Very, very good, very nice. Now the further I go, it's breaking along the layers, and then it goes in. Now you can see right there, it's actually doing very good. It's breaking down the layers, not along the layer lines. But up here, obviously, the weakest link was the Z-axis adhesion. Now this is to be expected for almost every FDM material. There are a couple out there now that don't do this, like PCTG, which is an insane material. Definitely check that out. But this, you know, interesting. It doesn't break as quick as some other materials like PLA would, but it still is a bit more brittle and a bit not quite as good Z-axis adhesion on super thin walls as, for example, CFPA6 or HTN. So I'll put that to the side right there. Very good. And the next test I'm going to do is I'm going to take one of these sample bars, and we're just going to see with the power of Rob what it takes to break and sort of how it breaks. We're going to watch if it bends before it breaks, if it shatters and explodes everywhere, and how the layer adhesion is inside this actual part. So I'm just going to go ahead and clamp this down in the vise right here. I'll put it up a little bit more, right around the logo. And then I'm just going to pull back, and we're going to see what happens. Ready? All right, it's going. Woo! Okay, yeah, once again, much more brittle than the other nylons. It didn't bend. Most of them actually stayed connected at least a little bit and had less of a forceful break. It wasn't like it didn't shatter. This definitely sort of shattered. Let me take the other side out of here, and we'll check out the layer adhesion and everything else. So, as you can see there, got great layer fusion. And actually, I don't see any, there's no little layer lines sticking out or anything like that. It broke like it was a solid object, which is pretty cool. Yeah, interesting. And it took a good bit of force too. It's definitely very rigid. So let's move on to the next test, and I'm gonna burn some of this stuff. Now, to protect myself and others from fumes, I've got the BOFA Print Pro 2 here, which has an extendable arm for extracting fumes. Now I like to use this thing for soldering in the office so I don't stink up the whole place. Anything with smoke and fumes, this thing comes in super handy. We've got it available on our website at fishminer.com/BOFA. We've also got other systems that have a full intake and circulation, so you can do a fully circulating thing. Anyway, less on that, more on the burning. I'm gonna turn this puppy on. And let's start with the vase. All right, let me just grab a chunk of this off here. Oh, here's a good little chunk. We'll do this super thin piece, and then we'll burn the thicker sample bar. All right, so I'm gonna hold it for 10 seconds. We're gonna watch if it lights on fire, stays on fire, how much it smokes, if it drips, how it just reacts to flame. I'm gonna start with 10 seconds, direct flame on this very, very thin part. Let's do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, and it barely caught on fire right there at the end. It's black smoke. Oh God, it's starting to drip. Yep, it's definitely about to. Let me just put that out because here I'm gonna drip onto this thing. I'm gonna do this again real quick. And then it becomes very soft, and you can, push it around. Ooh, all right. Yep, definitely not UL94 V0 flame retardant. Now, there's other materials that work great if you need something that is flame retardant. We got a lot of those on our website. We actually specialize in high temp, chemically resistant, flame retardant filaments, so definitely check out our site if that's what you need. Now let's do this again. Let's see how much it actually drips, because I used to do this with army men back when I was a kid in the backyard. Funny story, I set my neighbor's lawn on fire one time. Anyway, if you ask anybody, they'll tell you I'm a pyro. All right, let's see. Let's watch this drip. This is dangerous. Oh God. Getting a little out of hand there. All right. Well, it definitely, it lights on fire, people. It lights on fire. Interesting. Pretty quickly, too. Definitely not a slow burner. All right, let's move on to the next test. I'm gonna burn this sample part. Now, this is a lot thicker material, so it's not gonna light on fire as quickly. All right, so I'm gonna take this little sample bar. I'm gonna just do the same test. I'm just gonna light it on fire for 10 seconds and see what happens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, 10 seconds of direct, oh, it did light on fire. It did. The bar is on fire. All right, yep, that's not gonna stop anytime soon. I'm just gonna turn it off, make sure to get all that fume up into the BOFA fume extractor. This thing is so handy, I can't even tell you. And with this flex arm, man, oh God, just, it's great. It even takes particles when you're grinding stuff. Very, very cool. All right. So now you'll notice one thing, it did get shiny where it was heated up. That's something you can do with a lot of these nylon filaments, is you can actually use a heat gun, go over the surface and get a shiny surface finish. That is something you can do. You might be able to flash bake it, but that's something I've done with a lot of parts. I'm just gonna see how these letters react. Not much happening, but look how shiny that is. Here, I'll do the other side so you can really see. If I just heat this up, let's just give it some nice, melt the outer surface layer. Okay, that kind of bubbled, that went overkill, but with a heat gun, it's much more controlled and you can get some pretty cool looking parts off of there. All right, well, that is the burn part, the burn tests. All right, I'm gonna turn off the BOFA here. Once again, visionminer.com/BOFA for a variety of fume extraction solutions. visionminer.com/materials for this particular blend and a bunch of other blends of really cool materials that are all strong and high temp and awesome. And other than that, you can check out our other videos for full comparisons. We're doing a whole bunch of different comparison videos on all these different filaments for you guys because you asked. So let me know what you think in the comments below. If you got any questions, if you want us to test something specific, definitely leave a comment below. We will do it. Anyway, thanks for watching. Have a positive rest of your day, and I'll see you on the next video.